Hi everyone, welcome to a new video. We're looking at a new type of data today, and we're going to be looking at drawing this and analyzing it. We're looking at a specific type of data called time series data. Now what this is, as I've written here in the definition below, it's basically just data that is recorded at regular time intervals. So when we display this type of data, we're basically just looking at how one particular thing, one variable, changes over time. So when we want to graph this, so graphing these types of data, what we do there is the way we plot it is we have our time on the horizontal axis or on the x-axis, and then we have our variable, the thing that changes. This can be temperature, stock price. We're going to look at a couple of these examples. So variable on the vertical axis, because this is the thing that's changing with the time. And basically we have line segments connecting points on the graph. So we have line segments. So just these little straight lines connecting points on the graph. So, like I said before, these are different types of data representations that just show how one thing changes over time. So an example of this would be, for example, something like share price. So if we were to draw this, if any of you invest or know people that invest, you will know that shares have certain prices over time. So we can put our price here, and these change as the market changes. So as time goes by, that's shocking handwriting. So as time goes by, our price changes. So maybe it started really high, then it sort of stayed pretty stable but dropped a little bit, and then it suddenly plummeted down and then shot back up again. So something like this would look like a series of line segments. So if we connect this, we connect this, 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 and this, my price of my share is changing with time. Another example here could be, I don't know, temperature. So say we've recorded the temperature in one particular month, and we once again draw up our axis. Let's shift this up a bit, and on our horizontal we're always going to put time, because my variable in question, whether it's temperature or share price or anything else, is changing with time. So that other thing we're going to put on my vertical axis. So the time here could be, for example, different days. So we have day 1, day 2, day 3, day 4, day 5 of a month, and we're going to have the temperature on my other axis. So let's say it started really low and we kind of had an increase in temperature, then we went back down and then increased again here. What we're going to do is once again just connect each of these points, and we have what we call a bit of time series data. So it's occurring at regular time intervals, and we have some kind of variable on the vertical axis, something that changes with time. So now that we understand what these look like, let's just go straight into the question for this video. Now, this says the approximate population of an outback town is recorded from 1990 to 2005. So my time here is going to be my years. So years progress, the population changes, and my variable, my thing that's changing, is the number of people that live here, the population. So we're going to practice plotting this time series. So what we're going to do is we're going to write the time on the horizontal axis, and the thing that's varying, the thing that's changing on my vertical axis is my population. Okay, so we're going to start at 0, and basically we're just progressing through the years. So we've got 1990, 1991, etc. And we have our population here. So our lowest value is going to be 700. So let's just start with 700 here. And this obviously isn't fully to scale, so we're going to just draw this little line through to say that this is a broken scale. So we jump from 0 straight up to 700. And we're going to plot the next time, so that's 750. And we're going to keep going until we have all of these data points in my vertical axis, and we have all of these years in my horizontal axis. So you guys can try this at home if you'd like, or I'm about to show you what this completed table is going to look like. But we have this thing here. So we have laid out our years on the horizontal axis, and we're basically plotting what the population is at each of those years. And once we have a visual representation of this, like we have here, we can go about describing the trend of this data over a certain number of years. Here we're looking at 16 years. And that's what question B is asking us. Once we've drawn this, the main thing we're trying to do here is to get information out of our graphs and comment on how population changes or how temperature changes, how these variables are changing. So here for part B, we want to describe. We want to describe the population change. And we can clearly see here that the population from about this point down to, let's say, this one down here, we are pretty much decreasing. So we can see that my population starts at 1,300, it's going down. It momentarily comes back up, but then goes back down again. So we can see that from here to here, from this point I circled and this point down the bottom, we can see a pretty steady decrease in population. And then following that, from the year, what's this year, 1999, up here, we start to increase. We drop down a little bit, but we see a fairly steady increase in the following years. So here we have a steady increase. And because we're just taking data information here, we're not so much looking at exact right answer things like we would in other topics. We're basically just looking at trends. We're looking at describing what's happening and using that to tell us something further. That's really the essence of statistics and data. But we can basically say here, based on the information I've noted on the graph, we have a steady decline for about 9 to 10 years, and then it rises and falls in the last 6 years. I should say 5 to 6 years. So that's basically all that's required of us for these types of questions. We're just looking at data and then commenting on it. Now, for these type of time series data, one thing we're going to end on is that sometimes, and we'll see this a little bit later as well, our data looks something like this. So what if we draw something like this? And we connect our data points. So I don't know, let's say this was, this is like the temperature. As we connect the dots, we can kind of see that the drop looks very close to being a straight line. So the drop between these points, first of all, it's a downward trend. So it goes downward. And once we connect all the dots, they get very close to being a straight line. If we just go through here, we can sort of see it's very close to being straight. So this is a downward linear trend. So don't be fooled here, because we're using like a little line segments to join these. In theory, some of you might be thinking, well, isn't it always linear because we're drawing straight lines? What we're mainly focusing on here is the trend. Are we consistently going down or up in at roughly the same rate? That's what makes a linear trend. Something like this up here, it's not really a linear trend. As we saw here, it kind of shoots all over the place. We have like these like little decreases, then we have much bigger decreases, and then it evens out a little bit, goes back up, goes down, goes up. Like at different points here, we may observe a linear trend. So somewhere like here, for example, this looks like a relatively linear upward trend, but the data as a whole, it's not trending in a linear fashion. It's far too all over the place. When our line segments seem to line up and resemble roughly a straight line, so the points and segments, or line segments, resemble a straight line. This is when we can say something is a linear trend. But that brings us to the end of the video. We have talked about here how we can describe this time series data, what that consists of. We have our time on the horizontal axis and the thing that changes, the variable on the vertical, and we use this for a bunch of different types of data: temperature, share price, population growth or decline. And we've also learned how to actually draw these, construct them, and interpret them, actually get information from these, just try to figure out what it's actually telling us and what conclusions can be made. But thank you so much for joining me, and I'll see you in the next one.